In 11.2, most of this was really pretty easy. All the properties that you use, some of it's just adding them, so the identity one, you just plug the number in, really. So most of them are really pretty practical and pretty easy. However, two of them are not. And one of them, I have right down, yes I do. So this one is going to be like example 12, and it's finding limits using, in this case, factoring. So some of the other properties involved with a square root or in squares or various other things like that. This one in particular is factored. So let's write out this one. Limit x approaches -2 and x squared plus 5x plus 6 and x plus 2. We can't just simply put -2 in here like examples 1 through 11 pretty much do, because it's going to be divided by 0. So therefore, you're stuck. Can't do it. But you know you're factoring. So this becomes really easy as soon as you factor and cancel it out. So what we're going to do is factor that, if it's possible to factor. If not, then you'd have to work out other methods too. But if it's possible to factor, which of course most problems like this is set up that way, you just have to figure out how to factor. So in this case, two numbers that will multiply to C but will add to B. And so that looks like it's 3 and a 2, and there's not even negatives. So this was like an easy. +2 and +2, and those cancel. So now what we have is we can cancel that out and allow it to be the limit as x approaches -2 of x plus 3. And you can do the long way. One of the other properties shows that you split this as the limit as x approaches -2 of x, and then the limit as x approaches -2 of 3 plus and sum those. Well, and you know, it's easier just to put the -2 in there. So it's equal to 1. So that means the limit of that is actually 1. So if you were to graph it, actually, you would see, since that one is a, well, actually, this one factors as a straight line, but because of the -2, let's see, at -2, -1, -2, and 1. Open hole here. So at -2, the limit of it, as you get closer and closer to -2 on both sides, you get to closer and closer to 1 on the graph. So 1 is the limit. So graphing this would have shown you that. Okay, so that's another way to do it. And in this particular case, do it by factoring, and you can find it this one. Okay, now, another part of this, the last one is the one that's a little more complicated. Where is my example? Ah, here it is, okay. This is like example 13. In a way, it's still straightforward, but it's going to be finding the limit by rationalizing it. So find the limit as x approaches 0 of the square root of 16 minus x minus 4 separately, and an x down here. Okay, so what we're going to do is we're going to work on removing that and working this out. Right now we can't go to 0, we can't factor that. So what we're going to do is play with this. We're going to take this entire thing and we're going to rationalize it by, because that's minus, we can put a plus and then things will cancel out. Okay, so let's play with this. We're going to do square root of 16 minus x plus 4. Square root of 16 minus x plus 4. So we're just multiplying by 1 right now. No big deal. So this times this gives me 16 minus x. Because it's this thing, square root, times this thing, square root, is just that thing. 16 minus x. And then we can have this times 4 and this times -4, and they cancel out. Then we can do -4 times 4. So that's minus 16. On the bottom, now here we've got a bit of a mess. We have x times 16 minus x square root plus 4x. Now let's clean that up. I'm going to take this one, I'm going to come over here. 16, take away 16 is 0, but we have negative x on top. 16 minus x plus 4x. And what we have here is like a common factor. If I take x out of both of these, square root of 16 minus x plus 4, okay, then this x and that x cancel out. So what I have is a negative 1 over, and I guess we put the negative in front. I think I'm not going to. I'm going to put the negative on top for now, because it'll confuse things with the bottom. Here I have square root of 16 minus x plus 4, because I took the x out. We have a square root on the bottom. Usually rationalizing, and all the times that you've done rationalizing before, it's been for the purpose of getting rid of a square root on the bottom. Here the purpose is different. The purpose is to get the bottom of it, the denominator, something where 0 is not undefined. Okay, or will not make it undefined. If I were to put 0 in here right now, square root of 16 is 4, and 4 plus 4 is 8, I get negative 1/8. That's the limit. So, I'll show you that. 16 minus 0 plus 4 is negative 1, because that's 4 plus 4, negative 1/8. So follow the steps again here. That's rationalizing, not for the purpose of removing a square root, but rather for the purpose of being able to change the bottom so that 0 will not make it undefined, or limit what x is approaching to. It could have been a different number. In this case, by doing that, simplify it, cancel, and I get something that now when I put 0 in here, it doesn't make 0 in the denominator. So, limit as x approaches 0, I'm just going to put function of x because I'm tired of writing all that stuff, okay, is equal to negative 1/8. Okay, so in this kind of a problem, which is probably the only one you really can say is a difficult one in this one, it's a different concept than what you're used to for rationalizing. Okay? So you do it when, and the key here is if you see a square root, this is the kind of thing that you might want to consider doing. Okay? Can't even promise we have a test problem. I don't remember if I did or not. I'm still working on it there. But I am. I wanted to make sure you see that. So in section 11.2, these are the two types of problems that you need to be, well actually all of them you need to see. I have a number of test problems from that section, but I don't need to go through the other ones. They're easy enough if you're paying attention to the examples, and it's pretty clear what to do with those things.